Hello guys. So today I'm gonna starting the machine learning playlist. So today is the day first. So basically today I'm gonna starting the basics of machine learning. So basically the first algorithm that we are covering today is the linear regression. Basically linear regression is the basic and fundamentals of all the machine learning algorithms. So today I am gonna starting the first machine learning algorithm which is the linear regression. Okay, so firstly we will discuss about the linear regression. Okay, now coming to the board and then we will discuss. So here today gonna we are learning about linear regression. Mhm. Okay, so coming to the point, linear regression. So we already know that linear regression is the basic, or we can say that the fundamentals of every machine learning or AI algorithms that we are today in the universe, or that all the algorithms that we have today is the linear regression is the fundamentals. All the algorithms are derived from this. Okay. So now coming to the point, like why linear regression? Okay. So basically, the starting of all of these machine learning algorithm start from linear regression. So why linear regression? So suppose everything suppose everything in the universe that will be are normally distributed. And like we can say that approx 90 to 95% in the universe are things are normally distributed, and the normal distribution curve looks like a bell curve. This one, not this one. So like in the universe, approx 90% of the things will be look like normally distributed. So normally distributed means कि there will be some will be a mean will be zero, like mean will be zero and standard deviation but like 1 2 3 some what are there. So this is the linear like a normal distributed curve. Or in linear regression what happen, like every like most of the things follow normal distribution, so the linear regression will be a good choice to use first in the like algorithm to in any of these problems be you are solving. Suppose that we are solving a problem where like this is the room size. Suppose this is the room size and this is the price of that room. Suppose if you will buy a one room, this is the like one room, two room, three rooms and four rooms, and these are the prices of that room. Uh, if you will increase the number of rooms, then automatically the price will go high. This is the normal. And like normally everything will possible, like every will thing will follow this curve. So this is the there the normal distribution will occur in the picture, because if you increase the number of rooms automatically price will go high. So suppose that this is 1 lakh, 2 lakh and 3 lakh, 4 lakh. If you buy one room then it will cost 1 lakh and 2 something like that. So what will happen in linear regression? Basically in linear regression there will be a line which will try to fit, or which will try to like which will try to cut each and every point, pass through the every point, which will try. But sometimes what happens, suppose these are the prices, Sometimes this will not follow, we will cover not come in the same lines. Sometimes it will, if somebody is selling our house in 4.5 lakh and somebody which is having 4 rooms is selling at the below than 4 lakh, this will be happened sometimes. So that's why this is the problem. So what happened? This is the linear regression. The linear regression formula is by equal to mx plus c. Okay, this is the normal equation curve. Now what happened? It will not follow every time. Like here you can see that there is an error. This is the error in our data set. So error in terms of machine learning, we say that a cost function. Cost, what the cost you have, cost function we should say in the terms of machine learning. The error, ये जो, it is the error in your model that the you have fitted our line and it is giving some error. So this error we should say in terms of machine learning is the cost function. What the cost you have to pay for, like cost you have to pay, any cost you have to pay means the error you have to get. uh, this is the error, you have tried to fit a model but it is not giving the correct answer, so this is the cost. So the formula to find the cost is basically the you know the formula of mean. So y minus y of predicted का whole square divided by 2 of n. This is the formula. Summation of I, we can say the summation of I equal to 1 to n. N is the total number of points. So summation of y equal to I equal to 1 to n by minus by hat. By hat means by predicted का whole square upon 2n. This is the formula. We can say that to find the cost in your model. Now coming to the next slide. Okay, so now we know how to find the cost. Suppose that there is a model which is perfectly fit. Suppose it is passing through this point. At the point 1 it is giving 1, 2 is giving 2, 3 is giving 3, and 1, 1, 2, 2, 3, 3 is something like that. So what will happen in machine learning? Y equal to mx plus c is there. So now coming to the point of gradient descent. In machine learning, what we have done, firstly we assume any point. Like suppose you have any equal, like you want to suppose you want to find a solution of any problems in machine learning. Then if you try to solve like directly you finding the end, this will take some times. So what happened in machine learning, the scientists find a solution to finding the value of m. What they have done, firstly starting any random value of m and then find the error of that model. After finding the error, what they have done, uh, removing the removing the noise according to or minimize, we can say that minimizing the error of that function, so that we can get the right answer in the minimal time. But so we can say that this is the gradient descent curve is there. This is the gradient descent curve. So firstly what happen, we will start from any m. Suppose that we will start from here, any m value, and then according to that value we will try to find the minima of that function. we can say that this is the function of cost function of that value according to m. So we have to find that point where our minima is there. If you directly find the value of m, this will take some time and you even find not able to find out the minima. So the scientists discovered a equation. What this equation is? Mu equal to m old minus alpha. Alpha is the learning rate, and after that, this is the what we say that derivation of cost function. Cost function with respect to m. You know the cost function. Already we know the cost function. What is the cost function? Cost function is 1 upon 2n into summation of I equal to 1 to like n by minus by 8 ka whole square. So now you have to do the derivation of that function. So the new formula will become m new equal to m old minus alpha. Alpha is the learning rate. This 2 कट जाए is cancel. After that alpha by m summation of I equal to 1 to n by minus by predicted and x of I, this this one I upon this is the xi. Now this is the new formula that you will get. Now suppose you have a derivation function. You already know that if what is this, if suppose you will start from here, randomly assume a m value here, and you don't know the what the exact value of m. Suppose so, what happened at the time alpha is the learning rate. You have to assume at the starting alpha is the learning rate, and learning rate should be a minimum. You can assume any value, but sometimes in linear regression we will assume 0.001 approx. This is the best value to assume at the starting linear. But in if you go to in depth in deep learning, there you will not use this alpha as its value. Firstly it will be high, and then according to that problem this will go converse according to this some thing. The alpha is equal to alpha y is some under root of n something, I don't remember the exact, but this is the value. And after that, and then alpha is the learning rate is there. Okay, this is the exact meaning. Okay, so now what will happen? What is the value of m here? Here it is a positive, here it is a negative, you know. So after applying negative negative, it will be a positive value. And this is the error you already know. So what will happen? This will be a m equal to m old, but your old m is between here plus something. So your automatically you will try to converge from the right direction. Your m, you know that this is the fun. This is the basics you have to follow. Okay, so these are the linear regression. Now coming to our linear regression. Now we will solving a genuine problem, like what they did in interview they will ask you about the linear regression problem. What they will ask. Now we will solve. Here I think I have something. Why it is not opening? Opened. Okay. Okay. Okay, so linear regression is a fundamental statistical techniques. So okay, now basic assumptions. So in the starting of linear regression, you have to assume something. Like something means there are four five things are there. You have to assume firstly starting to the apply. When you will apply in a real problems of this linear regression, you have to assume something. Like something means there are four five parameters you have to follow. The first is linearity. Linearity means basically our variables will be linearly dependent to each other. Means ke we have seen already seen there, if the number of rooms will increases, then automatically the price will increase. So this is linearly separable. Means linearity is there in our data set. If the value of x is increasing, then the value of y will automatically be increasing. This is the meaning of linearity. Now coming to the whole homoscedasticity. Homoscedasticity basically means the variance of the residual will follow a normal curve. Means it's same as the normality. We have already seen that no, if many problems in the universe will follow a normality, like normal equations. So homoscedasticity means the our equation will follow these things. And independence. Okay, so independence means our these the variable there that are independent, like these are dependent, independent variables are there, there will be no correlation between each other. If there will be a correlation, then this will create a problem. So we will assume this thing before applying the any machine learning algorithm. If we are applying a linear regression, then we have to assume this thing. And normality we already know, our curve will be follow a normal distribution. If our curve will not follow a normal distribution, then we have to apply some transformation are there, like log normal distribution, box transformation are there, and the exponential transformation are there. You have to apply this transformation before apply linear regression. If in your data there is a normality is not there and independence are not there, then you have to follow this thing. Now coming to the advantages of linear regression. Why we have, like what are the advantages of applying the linear regression? Okay, so now the first, simple implementation and training. So that's why we are applying like linear regression, because linear regression is the basics of all the machine learning algorithms. So we know its implementation is very simple and training is also very fast. So that's why this is the advantages of linear regression. And everybody when starting the like all of machine learning or training these algorithms, the first algorithm they will apply in everybody's mind can will be a linear regression. So this is the advantages. Effective for linear data. Yeah, this is also good point. Like if our data set has a like linear relationship, abhi let's in the previous video we have seen that now, not previous video, same video we have seen, if the data is linear data means if our room size is also increasing, then the price is also increasing. That's the meaning of linear data. So this is also the advantages. If the our data is linear now, then this algorithm will work very good. You can't like, you don't even have to think. If there is a linear data, then you just apply this linear regression algorithm. Don't think about much. Overfitting control. Okay, so in linear regression you can also control the overfitting. Like how to control, there are many algorithms are there to overfitting, like regularization is there. I will teach you in the next video. Like this and loss of regularization are there, you have to apply this thing, then you, by avoiding the overfitting, if the your model will be overfitting. And also a dimensional reduction is there. If the like in dimensional reduction, what will happen, If they our data have a multilinearity in our data set, then we apply like Damson reduction algorithm to avoid this overfitting. And cross validation also we can apply, regularization. I will teach you all of this thing. Now coming to the disadvantages, why we don't have to apply linear regression on some of the algorithms. Because the first thing is feature engineering. Suppose sometimes what happen, the data is not in a good manner. Suppose there is a many, suppose there is a first thing, there's a many missing values in your data set, then don't apply linear regression. Because linear regression don't work on the missing values, so you have to manually do a feature engineering, like fill these values, missing value by mean, median, mode or something you have to do, and many things in linear regression. So this is the first problem. And the second, in feature engineering, what happened, suppose there is a collinearity is there in your data set. Suppose there is a 50 columns in your data set and 20 columns in your data set have a highly correlation. Highly correlation means there is a correlation mm, very high, greater than 90%. Then you don't have to apply linear regression. Firstly apply, you have to do feature engineering and then apply correlation. So this is the problem. Correlated feature that I already discussed. Correlated features are there, like suppose there is 50 columns and 20 columns are high correlation, so will create a problem. You have to do a manual checks and remove, apply these changes. That's why I don't use linear regression in that case. Sensitivity to noise and overfitting. Okay, this is the also a disadvantage. Sensitivity to noise and overfitting means this will be sensitive to noise and overfitting. This means suppose your data set is something like, wait, I will show you in a graph. Suppose this is your data set is there. So this is your linear line, and suppose this is your again note here only. Suppose if in this data set there is one point is also there, which is here. By this point only, this is the basically we know this is noise point, or we consider outlier, outlier or noise. By coming to this point only, our line should look like this now. You see that now the error will be very high. So this is the of meaning of sensitivity to noise. Means if there is any noise point will come, then your model will be sensitive to that point. Like this will not convert, not work in good when this will be some noise is there. So this is the problems, and this is basically a disadvantage of that problem. Now coming to the feature scaling part. So is feature scaling is required or not? Yes, basically is required. Feature scaling means basically okay, down feature scaling basically means normalize our data set. Normalize means convert all these value into a zero or one. There are many types of feature scaling are there, like min max scalar, standard scalar, and something two three or many available in the market you can use. So we have to apply this feature engineering, like feature scaling. Because what will happen, suppose your like gradient descent curve is there, and if you don't apply feature scaling, then this will take many times. Like suppose you have a 50 features and they are a very high value, like 1 lakh 2 lakhs are there, then you have to do very high computational power you have to require. So for that this will take some time. So if you will do feature scaling, then the time will be reduced. So that's why we have to apply feature skilling. So feature skilling required. You have to apply feature skilling. If you will apply, then this will be good for your machine learning model. Missing values now. We have already discussed this will not fill this missing value. You have to do manually. So this is the also not a good practice to, like, this will not sensitive to missing values. Like linear regression is sensitive to missing values means this will not fail automatically. You have to do manually all of these things. Now coming to the outliers, it is also sensitive to outlier. We have already discussed this one, because if the one outlier is coming, then this will, your curve will be shifting toward the outlier, because to minimize the errors. So this is the problem in our in the linear regression. So this is also a sensitive to outlier. Additional points. Now coming to the additional supervised learning. Yes, linear regression you can't apply in unsupervised algorithm. This is a supervised machine learning algorithm. So yes, overfitting and underfitting. Okay, so these are the common issues in machine learning where the model and either memorize the training data too closely, overfit, fails to capture the underlying pattern and prediction. Okay, overfitting and underfitting means basically our machine learning model will be training on this data, and not if we this will not know the like the testing data na. So our model will sometimes will be overfitted, and if you will go to the production level, that will create some problem. So this is the problems, house price and flight price prediction. In these problems, if you want to solve like house price prediction and flight prediction, then you can use these algorithms. And when, like, they are already using, because house price means if the number of rooms will be increasing, the price will automatically increase. So basically there is a linear relation. If you will think there is a linear relationship between x and y, like independent and your dependent that will be predicting, then you just apply linear regression, don't think about much. Now further explanation. Explore polynomial regression. This will be covered in the next sometimes after. Okay. So this is the example. You can see this is the linear regression example. This is your data set. This is your x value, and this is your dependent variable pi. And this is the your fitted line. You can see that there is some error also there. Now, so today I have covered the linear regression. I think you will enjoy the video. Please share me your thought and please comment me in the video. Like, basically I know I have not made a good video, because this is the first day that I am making the video. Basically I have started this channel to improve my English communication English. That's why I am trying to, like, enhancing my speaking English. So please help me bros to uh, improve my English communication English, because I know my communication skill is not good, but still I am trying to improve my communication skill. So please bro, help me, subscribe my channel, comment it down as you can do. Also, I don't suggest you to share my video to your friends, because I have not done any good thing, but still trying. I think in future I will be a good communicator, and I think my channel will be grow. But basically I will create this channel to improve my English to in a comedian way. Please bro, motivate me by subscribing. Thank you guys. If you would like my channel, thank you.